the main object.
Hi, this is Sampath. I mainly discuss about topic research algorithm in the course of artificial intelligence. The main abstract is the search technique or universal problem solving methods in the artificial intelligence. These search algorithms were generally employed by the rational agents and problem solving agents in the advanced artificial intelligence to solve a given problem and provide the best outcome. And next slide, we are seeing one example of travel map. Travel map main project objective. The main aim of this project is analyze, implement the search algorithm. We are using the depth first search and breadth first search and a uniform cost search and a greedy best search and a star search with the local beam K2. This is the given travel map. Next, we are discussing about depth first search. Depth first search algorithm is used to travel node by always expanding the deepest nodes. The search proceeds to the deepest level until the nodes has no successors. As those nodes are explored by or marked as visited, so that the search goes to the next deepest node that still has unvisited successors. Depth first search uses stack with flows, uh, last input, first output. Hence, stack is used in the depth first search. This is the depth first search algorithm we are using in the project. And this is the depth first search flow chart. We are starting and determine the nodes in the travel map and determine the neighbors for each of the nodes and the route. Ask the user for the start nodes, and then it will be yes, it will be go to the next stage. If it is no, it will be repeated the steps. If it is yes, mark all the nodes are unvisited in an array. Create stack and push the root nodes to the stack, and y stack is empty. If it is true, it will be go to the next step, or it is fails, return the output at the end. It will be then it will be true. Set root equal to peak to the top of the stack and pop the stack and the route visited and travel through the route listed. We are two kind of things here we are seeing in the first stack. Then it will be go to the output, update the rooted as visited and a neighbor visited, and end. It will be completed. And next, this is the output of death first search. This is the starting node of A. If you starting with A, this is the output, and starting with B, this is the output, and starting with K, this is the output, and starting with S, this is the output, and starting with Y, and this is the output. We already run this one. And next, we are going for the breadth first search. Breadth first search travel algorithm travels a graph in the breadth-wise manner and store the visited nodes in the queue. It uses a queue to store the nodes of each level when they are visited, and then these nodes are visited one by one. After that, the adjacent nodes are visited. The terminating condition is when the queue is empty. In breadth first search travel, one node is selected as a starting position, and this selected node is visited and saved in a queue. This is the breadth first search. And the breadth first search algorithm, we are using this simple form of our view of algorithm. Select one node, visited it, and save it in a queue, and adjacent nodes for starting node and save these. Visited the adjacent unvisited vertices and save in the queue. If no adjacent vertices is found, remove the first vertices from the queue. traverse until the queue is empty. We are following these steps in the breadth first search algorithm. And this is the application of breadth first search. We are using the unweighted graph and P2P network in the breadth first search. Unweighted graph like BFS algorithm easily create the shortest path, a minimum spanning tree to visit all the vertices of the graph in the shortest time possible with a high accuracy. If you go with the P2P networks, BFS can be implemented to locate all the nearest or neighboring nodes in the P2P network. This will be find the required data faster. We are using the whichever is the best one, we are using that one in the BFS. This is the BFS rules of algorithm of BFS. In a queue, first come, first output. We are using that one in the BFS algorithm. Data structure is used by BFS. You can mark any node in the graph as start and start data. BFS, all the nodes in the graph, keep dropping them as completed, and BFS visited and adjacent unvisited nodes mark it as done. Insert into a queue. Remove the previous node from the queue in case no adjacent node is found. BFS algorithm until all the nodes in the graph are successfully traveled and marked as a completed. There are no loops caused by BFS during the traversing of the data from any node. This is the rules of algorithm, and this is the pseudocode for BFS we are using in the project. And this is the flowchart of BFS, visiting and mark node, starting node, and this is the node into the stack. Then it is go to the queue empty. Like if it is empty, it will be go end. Now it is not empty, then it will be go remove node from the queue and point to first adjacent node, and it will be go to the next stage like end adjacent list. Then it is yes, it will be go to the end. If it is no, it is go to the node already visited. Like we are using in the BFS this method, and this is the output of best first search. If node is starting with A, this is the output. If a node is starting with S, this is the output. If it is node starting with J, this is the output. And this is starting with the node D, this is the output. This is output we are when we are running the BFS in our project, this is output. And next we are going for greedy best first search algorithm. Always select the path which is the best at the moment. Combination of BFS and EFS, we are using here BFS and EFS both together, and we are like f of n equal to h of n. The evolution function is f of n equal to h of n. Ignores cost of previous travels path. Solution are not optimal. This is the pseudocode for the greedy best first search we are using in our project. And this is the flowchart of greedy best first search. We are using first we are start the node, and then greedy best first search, and we stay nodes. And then if it is AS, it will be go to the while current node, and it is false, it will be go to the end, and it is true, it is go to the current node or starting node. Then it will be true, it will be go to the path new string, and if it is false, it will be go to the some other like another node. Then it will be go to the goal node. If it is true, add goal node to the path and print the path to the terminals. Then we will get the output of the database for search. And we are using this one greedy best for search output when we are starting a node A, we will get output this one. And if we are starting with the node Q, we will get output this one. E, this is output. Yeah, Then we are now discussing uniform cost search. Uniform cost search algorithm determines travel path through calculation of lowest possible distance of travel between the source node and distance node. Utilize the priority queue to the determine path of travel. Enqueues with the children node on the path of travel with the lowest cost. We are using this method. This is the algorithm rules we are using in the uh, search method. Add the source node to the priority queue. Explore the nodes adjacent to the source node. Perform these steps as long as the queue is not empty. Remove the nodes with a high priority. Node with the less cost get priority from the queue. If the removed node matches with the goal node that we have defined, stop the algorithm. Print the all nodes in the path with the least cost to reach the goal node. We are using these algorithms, and this is the flow chart for the Unicast for cost search. We are starting with the node. Determine the node and distance cost. Determine the source node and goal node. Creating the priority queue with the source node. Export the adjacent nodes for the queue. If it is true, it will be go to the queue is not empty. It is false, it will be repeated the steps. And then it will be go to the remove node with highest priority from the queue. Then if a node is distance is very shortest, it will be go to then next one, and this is the stop. Then we will get the final output. Now, this is the flow chart for the Unicast. And this is the implementation. We are using the Unicast cost search. Utilize the graph interface, edge and vertex, establish the parameters for the utilization in the UCS. Uniform cost search algorithm class helps code perform algorithm determines the flow of encoding, enqueuing, decoding according to principles of uniform cost search. Main class maps different values to the nodes names and call an uniform cost class to the determined travel path from the different source node to the destination. Uniform cost class utilize the mapping to create adjacent matrix for the 20 nodes. And this is the output of Unicost search. When we are starting with the node here, this is the output starting with the queue, and this is the output. Then we are discussing A-star search with the local beam. Instead of keeping track of one state, the local search method keeps track of k. It's starting with a set of k states that are generated at the random. All k states successes are formed each stage. The algorithm, if any of these a goal, otherwise it repeats the process of selecting the best k successes from the entire list. Local beam search and maintain the k state at any given time. These states are created at random at first. The objective function is used to compute the successes of these k states. The algorithm will come to the halt if any of these successes is the maximum value of the objective functions. This is the local beam search flowchart starting with the node. Insert initial state node A equals 16. Then it will be go to some example we are taking like a BF 17. Same thing we are using in our project. This is the A-star search pseudocode we are using in our project. This one also. This is the result output, final output of the A-star search local beam. If you're starting with node A to G, it will be this is the output of our A-star. And then our final conclusion is project helped us establish travel path based on different search algorithms. Applying the different search algorithms benefited our in the depth understanding of each algorithms thought as possible application for various scenarios. Thank you.